What has existed before will exist again. In the history of physics and mathematics, there is a remarkable theorem known as the Poincare recurrence theorem. It tells us that under certain conditions, all seemingly random motions in the universe will eventually return to their original state. In a closed system with a finite volume, if energy is conserved, the state of the system, over an infinitely long period of time, will almost certainly return to a state extremely close to its initial condition. This is Poincare recurrence. Poincare recurrence is not a philosophical declaration that all things must eternally cycle, but a rigorous mathematical theorem. Its validity requires several conditions. The number of particles, energy, and spatial volume must all be finite. There must be no energy dissipation within the system, and the timescale required for recurrence is often extraordinarily long, possibly far exceeding the current age of the universe. In other words, over macroscopic timescales, systems evolve toward disorder. Yet given an almost infinite amount of time, they may indeed return to their starting point. Under the finite resources and energy of the universe, time is not necessarily a straight line, but a possibility of cycles. When we gaze at the starry sky and believe that everything is heading toward annihilation, Poincare recurrence reminds us that the universe may not face an absolute end, but may instead await rebirth in another form. Perhaps in a previous cycle, you have already watched this very video.